Animating arm and leg can be very complicated, especially when you want to create a contact pose of the elbow or the knee. Let's find a way to make it easy. Hi everyone, Pierrick from P2 Design here. In this video we will learn how to rig an elbow so that we can lock it in place while still animating the body and the arm of our character. This can be applicable to legs too. Let's get started. To make sure that you can follow along, I will be using one of my existing rig, but I will get rid of the arm rig so that you can reproduce it. So I will delete all the controller bone, but I will keep the deformation bone so that I don't have to remake all the weight painting stuff, and we can directly go into mechanism. We will first rebuild the forward kinematic and invert kinematic chain and then add this pinnable elbow mechanism. In this video I will be rigging the arm chain. I won't be working on the shoulder. And we need to be able to isolate the rotation of the arm from the shoulder, as in the example shown here. If you don't know how to create this kind of mechanism allowing you to follow or not the rotation of a bone in the chain, check my YouTube video I've previously made. You will find the link in the description below. In edit mode, I will select the free bone of my arm chain. I will press Shift D, then Z and 0.1 to offset this first duplicate of 0.1 on the Z axis. Then I will rename it from target to control forward kinematic. This is going to be our forward kinematic chain. I will disconnect the bone by pressing Alt P and then scale them down a bit so that we can recognize them easily. This will only disconnect the bone, but they will still be parented. I will then duplicate a second time my chain and offset it by 0.2 on the Z axis. This is going to be our mechanism chain for the inverse kinematic mechanism. I will then build this inverse kinematic mechanism, so it's very easy. From the joint of the wrist, I will extrude a bone on the y-axis so that it's aligned with the world space. I will unparent it by pressing Alt P, and then I will parent the hand bone to this newly created controller. Unparenting the controller allows us to then move the hand bone in space as well. Now in pose mode, I will make the controller selected and then the forearm bone active. Press Ctrl Shift C and add an inverse kinematic constraint. I will select the constraint bone. In the bone constraint option, I will set the length to 2 bones, the forearm and the arm bone, for the inverse kinematic chain. Then in the bone option, I will search for inverse kinematic and I will lock the Y and X axis so that the elbow will rotate only on one axis as it will do in real life. I will also set a slight IK stretch so that I can stretch the arm without destroying the inverse kinematic mechanism. I will then extrude another bone from the elbow on the Y axis also to make it align with the world space, unparent it and move it on the Y axis. This will be our pull target. The pull target allows us to give an orientation for the elbow. So I will make sure to parent it to something, so I will parent it to the root bone, even if it doesn't really matter in our case. And then I will give it a relevant name. Once done, I will go back into pose mode, select the forearm with the inverse kinematic constraint and set the pull target. Once you've set the pull target, the elbow will generally flip because Blender needs a base angle to align the elbow with the pull target. From there, creating the switchable chain is pretty simple. We will add a copy transform from the forward kinematic chain onto the target chain, and we will repeat the process with the inverse kinematic chain. Then we will just create a custom property that allows us to switch the influence of those copy transform. So for each bone of the forward kinematic, I will select them first, then select the corresponding target bone, press Ctrl Shift C and add a copy transform. I will now repeat the process with the mechanism bones of the inverse kinematic chain, selecting the MCH arm and then selecting the target arm and adding a copy transform. I will do the same with the end bone. So you've seen the chain offset as soon as I've added this constraint, and now the whole arm is controlled by the inverse kinematic chain. If you don't feel comfortable with this tutorial so far, or if you want to level up your rigging knowledge, I advise you to take my latest course, The Art of Effective Rigging in Blender. To be able to switch from the forward kinematic to the inverse kinematic, we need to create a custom property that will allow us, in a simple click, to switch between those two chains. I already have a property bone in my rig. It can be whatever bone you want. Then in the properties panel of this bone, I will create a new custom property and I will name it armikfk.l. I will then right click on the value of this property and copy the data path. From there, I will select my target chain which has the constraint. I will rename it fk.ik so that it's easier for me to find it back. And then I will right click on the influence, add a single driver, switch to average value, switch to single property, source the armature, and press Ctrl V to paste the data path I've previously sourced in the bone custom property. This peak influence means there is a driver onto it. I will right click and copy the driver so that I can then paste it on every copy transform I have along the chain. This way I don't need to recreate a new driver each time and remake the setup. I just need to select the target bone, go on to the second copy transform, right click on the influence and paste the driver for the forearm and the end bone. Then when I select my property bone, I can see in its property panel that I can switch from FK to IK flawlessly. I hope you are enjoying this tutorial so far. Don't hesitate to ask me in the comment whatever you want to learn about rigging or animation or anything in Blender. If I can help, I will try. Now that our base mechanism is done, we will do the elbow pinning mechanism. So from the target chain I will extrude a new bone and I will clear the parenting. You can then parent it to the root bone if you want. I will give it a relevant name, and since I want to override both the FK and the IK, I will be constraining our target chain. We need the arm bone to be pointing to this newly created target and the root of the forearm bone to also be stuck to this newly created target. So we need both a tracking and a stretching constraint. So what I will do in pose mode with my pin selected, then I will select the arm bone, I will add a dumped track constraint and then a stretch to constraint. So later on in rest pose, I will have to reset the stretching of the stretch constraint. Blender recalculates the base stretch value of the bone, so it's better to do it whenever your character is not posed. Since my pin controller was not in its default pose, and since our bone chain both for the forward kinematic and the inverse kinematic are not aligned in the ring at this moment, it's normal that it doesn't perfectly fit, but later on I will reset the stretching once everything is aligned and it will work properly. I will just hide those two constraints just to make things clearer, and then I will jump on the forearm. So the forearm has two copy transform, the one from the inverse kinematic chain and then the one from the forward kinematic chain. On top of it, I want to add a copy location from the pin bone so that it will stick to the pin bone. And that's what we have. And you can see that the previous constraints are still working, but I want the wrist to follow the end bone. So what I will do is that I will add from the constraint end bone, I will add a dumped track and a stretch to constraint. So the combination of dumped track and stretch to allow us to have this stretching to a target, and the dumped track tend to fix twisting issues. So now I can reactivate or unhide the previous constraint on the arm bone. From there, we will have to realign all of our bone chain, so I will get back into edit mode, select both the forward kinematic and the inverse kinematic chain, and move them on the z-axis by -0.1 and -0.2. These are the offset value I've set before to offset those chains to work more clearly. Since my bones are now in their default position, I can reset the stretching of the bone. If you remember a few seconds ago, I had this little issue where the bone were not scaled properly. So now I can go to the stretch to constraint and reset the length of the bone. I will have to repeat this process a few times because I'm tweaking the rig. Now focus on the end bone and the forearm bone. You will see a slight delay in the position of the end bone. This is a classic bug whenever you have a circular dependency. My hand bone is the child of the forearm bone, but it's also constraining the forearm bone. So it means that the child is influenced by a bone and it is influencing it also. So that's a problem. But since it's using a copy transform, I will just unlink this bone by parenting it to the root bone and it will fix the problem. Since it seems I have fixed all mechanism bugs, I can now create my custom property. So I will select my property bone, go into the bone option, and in the custom properties tab I will add a new property. I will call this pinnable.l and I will press OK. From there, I will right click on the value and copy the data path as we did previously in the video when creating the switchable forward and inverse kinematic chain. Now I need to set a driver on every constraint that use the pin elbow bone. I will start with the arm bone by creating the driver onto the damped track constraint. As usual, I use average value, single property of the armature, and I passed the data path. From there I will copy the newly created driver and paste it on every constraint bone that need to be switched on or switched off. Then I will run a pair of tests using the property bone and switching from IK to FK, and I felt like the rig was working properly here. Using this setup allow me to keep the rotation of the base of the arm. So let's say you have a rubber limb with multiple subdivisions. Depending on the hierarchy you've set up this pinning elbow, you will be able to keep your rubber limb and on top of it having this pinning elbow. So if you want to know how to create rubber limbs, as usual, I invite you to check out my latest rigging course. So while I was promoting my product to make some money, I've just symmetrized the rig. To do so, you just go into edit mode, select all the bone on one side, right click and select symmetrize. Then you have to reset all the drivers on every bone. So I'm just copying the driver from the left side and pasted them on the right side. Since I've created custom properties with the .l.r suffix, I just have to change this in the data path. So then I've reorganized all my bone using the bone layer manager by Fin. You will find the link in the description as usual. And I thought I was done, but there is still a little problem we need to fix. While I was creating the demo animation for this tutorial, I found that there was a bug whenever I was rotating the spine of my character. The end bone and the forearm bone were also rotating while the arm bone was staying in place. And this is because they were following the rotation of the arm bone due to their parenting, but also due to a lack of constraint. So at some point I've decided to switch to inverse kinematic for my animation, but it was super disappointing because my goal for this tutorial was to create a reliable and versatile rig mechanism, and it wasn't the case. So I just stopped animating and then I got back to the rigging stage to find a solution. So what I want to point out here is that animating at least a bit will make you becoming a better rigger, because this is where you will face the real problem with your rig and its limitation. And this is also where you will learn whenever a feature is useless or is overkill, or whenever it's really a mandatory feature. Here I'm back onto my rig and I've only displayed the forward kinematic mechanism and the pinning elbow. I will play the animation again and you can see that whenever I rotate the torso, the end bone is also moving in space. So if I want to lock the forearm bone in place, I just have to select first the pin elbow controller, then the forearm, and add a copy location. This way, the forearm bone will still rotate whenever it's following the arm bone, because it's a child of the arm bone, but whenever it's not rotating, and this is why isolating the rotation from the shoulder is very important, the forearm bone won't rotate. If I reactivate the follow rotation, you can see that it's rotating and it's ruining our mechanism. But whenever I isolate the follow rotation here from the shoulder, the forearm bone is not rotating anymore. If you remember, in our target bone hierarchy, we have constraint the arm bone with a damped drag and stretch to constraint. So I don't need to re-constraint the arm forward kinematic bone with the same constraint. These are override later on in the hierarchy. From now on, this copy location constraint we've just created, I will just copy and paste the driver I've set before to enable or disable the pin elbow function. I must say that this rig was a little more complicated than what I was expected when Paul asked me to create this tutorial. But in the end, I was able to create this animation flawlessly, and you can use the same mechanism to pin the knees of your character or whatever joint you have. You can also do this on more complex bone chain if you want. If you have any question, don't hesitate to ask me in the description below or tag me on Twitter. This is the end of this video. I hope you've liked it, and I will see you in the next one. Bye!